Hello everyone. How many of you would have been in this dilemma, specifically when working on AWS, Amazon Web Services, and if you have to work with a microservices architecture, which container platform to choose? Whether should I go with ECS or whether should I go with EKS? Hang tight, watch till the end to get a clear distinction on when to use which one. This is the agenda of the presentation, where I'll walk you through the container orchestration, the introduction, the ECS overview, as well as the EKS overview, provide the comparison of both. I'll provide a nice tabular comparison so that it could be referenced, use cases and considerations. Because we have, working with customers, seen and suggested many organizations go about different ways depending on many factors. And that is where the decision factor is going to come in. So this is where we and conclude as well. Now, coming to container orchestration, one of the things that we have seen is that there has been a fundamental shift from traditional infrastructure to cloud-native paradigms that in turn have been driving innovation and efficiency. The containerization revolution has been also at the forefront of the revolution, where one needs to understand the pivotal role of containers in modern application development and deployment, which is where this diagram, which is, I think, provides a good understanding of how containers fit in. Because earlier we had physical machines sitting on the data center, and that is where we used to deploy a lot of the applications, and they would run out there. Then came virtual machines, where on a VM, we would have a hypervisor, and on the hypervisor, there would be further VMs that one could have, and one VM could be of Windows, one VM could be of Linux. So you could kind of have multiple applications sitting on the VM and provide clear isolation on how the application, without providing any interaction between the two applications. So you would have the guest OS, which is the virtual machine. It could be Windows or Linux. And then you would have the binaries required for running the application, and then the application would be installed. Now, this was good. And a lot of applications still work on VMs, and they are suited to work on VMs. It's not that everything is good for containers, but that is a discussion for another topic. Feel free to put in a comment if you want to have, you want me to kind of create that comparison of when to use virtual machines and when to use containers. But you would have heard a lot of times during your development, it works on my machine. It doesn't work on your machine. So that is something that we have constantly heard, specifically in the software development cycle, that something works at my machine while it doesn't work at their machine. And the same thing happens when we start promoting code from a development server VM to a QA environment, to UAT, to eventually to production. So that is where the cycle continues, because the reason for that is because some binaries could be there in a particular VM, which are missing as part of the package, and that in turn is causing the application issues. The container provides a little bit of abstraction on that segment. Now, this is where you see over here the picture to the right, which provides the containers overview, where you have a host operating system. And on the host operating system, you just have a container engine, which provides a little better resource usage of the VM, of the virtual machine that could be required. And there you would have, like in a container, you would have a particular binaries. It could be a Linux binary. It could be the application dependent libraries that are required. And then you have the application. And this container is what is pushed to a repository, which would be used for building for your pipeline in subsequent environments. Thus, it minimizes the chances of the scenario that it works on this machine, but doesn't work on this machine. And then as well as like it works on one environment and not on the other environment. If we could kind of come down to the microservices architecture, which essentially is that the smallest effort of task, you could containerize it and provide more granular orchestration between the services. Now, this is where we have how the traditional infrastructure that we have been working towards and how they have been kind of moving out of. That is, we have moved from traditional infrastructure to virtualization, and then eventually to containers, and we're kind of moving into the cloud native paradigm. So that is a journey that we have been having across the software lifecycle. And this is where the AWS container services, they provide the way for seamless adoption of cloud native practices. And now, why orchestration matters? Containerization has revolutionized the way we develop, deploy, and manage applications. It brings several benefits, including enhanced portability, scalability, and resource efficiency. As applications become more complex, effective orchestration becomes crucial to streamline deployment and management processes. Now, you would be asking, why should I really have orchestration? I'm fine with my application running on a VM, so why does it matter to have orchestration in place? So orchestration, it simplifies the deployment and scaling of containerized applications. It manages the lifecycle of containers, ensuring that they run efficiently and reliably. Orchestration also enables seamless communication between containers and automates essential tasks. This is where the whole framework of the container orchestration comes into picture, so that you as the developer can just focus on development while the operation person can focus, and a lot of the complexity is taken out of that and moved to the orchestration system over here. So what are the AWS solutions for orchestration? AWS provides a lot of robust solutions for container orchestration. But for the sake of this presentation, and there have been new services that keep coming out, we're just going to focus on two ones, which are the most matured, and we have seen a lot of customer adoption for these two services primarily. One is the AWS ECS service, that's also called Elastic Container Service, and the other one is called the EKS service, or Elastic Kubernetes Service. So without further ado, let's get on to the next topic, which is service. Now, this is a fully managed container orchestration for running Docker containers. It abstracts infrastructure complexities to provide a straightforward approach for container deployment. There is seamless integration with AWS services, such as IAM, or Secret Manager, or KMS. There is native support of using other services which are very popular, which applications we have seen frequently use, like SQS, which is a simple queue service, as well as you would have EFS, or you could have shared repository if an application needs to have that. So that is where they provide a lot of easy integration with AWS services. There is seamless Docker container deployment, because what AWS provides is Elastic Container Registry, where one can provide we push the code to the repository. The repository itself can scan the container to ensure there are no vulnerabilities, and thus providing a seamless experience rather than one going to, say, putting in GitHub in a separate container repository, or going to a JFrog, it could be a private repository. AWS provides a lot of this out of the box of the repository, and you could have it a lot of parameterized. So let me jump to the console and show you what exactly I mean by the AWS services. So I have logged in. This is the login for AWS, and the ECS service, if I have to choose, I could just type in here, and I could come as part of I open in a tab. So this is where one would land for the ECS service. Now, I'll get to the part where I create the ECS service, but let me first show the repository as well. Now, this is where you see it's the ECR repository. Clicking on it, it's going to open the repository. Now, I have not set up anything, so please put in the comments if you want to have me create another deep dive tutorial specifically on ECS. But for the sake of time for this presentation, I didn't want to kind of go long and show, but this is where you could create a repository. You have the option of creating a private and a public repository. A public repository is such as like GitHub. You would want to have the setup done required for other applications, but this is where you could create it. I could create it as ECS repo, or I could put it as container repo. I would want to have it as private for me. Now, this is where I was saying you could have the image scan settings done. That is like, if you want to have your container scanned, you could ensure they are scanning properly. So, it should only accept lowercase letters. Let me just do it. This is where you could also have encryption in place. Now, we definitely recommend to our customers to have KMS enabled, and we do recommend to put our own KMS key rather than AWS's key. So that is a topic for another time, but this is something that we recommend. For now, I'll keep this disabled because I just wanted to show you all. This is the repository that is used, that we could use as part of the ECS service creation. Now, this is the repository that you see. You could come in here. You could come to the repositories setting out here. You could put the permissions for the setting repository. I could create the policy that which particular principals can access the repository. I could have lifecycle repository when I want. What we have seen a lot of times happen is when there are a lot of deployments happening. So this repository could have a lot of stale or very old versions for which you would want to have lifecycle policy so that the older containers, they are cleaned up. And that is where your cost efficiency also improves. And this is where you would be having images. I have not pushed anything, but just I wanted to show you. Let me know if you do want to get into details of this, and in my next video, I'll show you how to go about creating these images as well. But this is the repository that is created. And you could see that it'll provide you all the push commands that you could run from your local repository, where this is for Windows, this is for Mac. And then if I come here to the cluster, now ECS, what I would be able to do is I could come here, I could create a cluster. I could say ECS cluster, and I could, the namespaces, if I want, I could choose this. So this is where the namespace would be essentially like it's going to be similar to Kubernetes and something we can walk through. It allows to specify a group of services that make up your application. And now for infrastructure, again, other options. That is, we have AWS Fargate and we have Amazon EC2 instances. AWS Fargate is a serverless model, but also it is a black box model in the sense that EC2, it provides flexibility that one can SSH into the VM or and then be able to check the container status or whether the logs of the container. So that is something one can feel more comfortable with. But with serverless, it is with Fargate, you will just deploy your applications and AWS takes care of the rest. That is the scaling as well as the management, thus leaving you with minimal work. But again, with any PaaS service, which is a platform as a service, it'll be a little more expensive compared to a VM that you manage yourself. But for this video, I'll just choose serverless because if I have to choose EC2, I would have to provide a key pair and all those things, something that I'll kind of skip for now. And you could see there is a monitoring option here. Container Insights, it provides a little more managed monitoring about your particular container, how it is responding. Something we do recommend our customers to enable. This video, I'll just keep it disabled. Tagging is definitely we recommend. The cost center, the billing code, or the organization, any of those metrics that are pulled out for reporting purposes, something we definitely recommend. But I'll just hit create. And as you can see, it will create a cluster for me. So while this is being created, we'll go on to the next slide, which is Kubernetes. So Kubernetes, now this was created by Google and it was then eventually published to the community. And AWS has its own flavor of Kubernetes, as do other organizations. Azure Kubernetes service, Google has its own as well, which is Google Kubernetes Engine. But Kubernetes, EKS delivers a fully managed Kubernetes service that combines the power of Kubernetes with AWS's scalability. Few of the features that EKS provides is easy cluster management. It simplifies the cluster creation, scaling, and maintenance. Like ECS, this also provides a lot better integration with AWS native services, such as elastic load balancing, IAM, and more like SQS if you require. You could also have seamless integration with Kubernetes environment. Now this is the EKS, it again adheres to the industry standard. It tries to keep up with the industry standards that are there, the pace that is there. And so you will see the latest and greatest versions of Amazon does manage as well. So something to look into. Now the next one is compatibility with Kubernetes tools. Now this is where, it harnesses the power of open source container orchestration, and along with it, there are a lot of tools that the community has that EKS, it provides. That is, it has access to the extensive ecosystem. It provides cluster auto-scaling. A few of the tools that are there, like kubectl is there. It's supported by Kubernetes. You have auto-scaling as part of the setup as well. And that's based on the workload demands. You have RBAC policies, role-based access control policies that provide fine-grained control over access and permissions through roles. And this is where Kubernetes provides a lot of these tools that are supported as part of the EKS. And likewise, going to the console to show here, Now, let me come back to the ECS. This is where I was seeing that please try again for ECS. If I have to redo this. Now, so moving to Kubernetes, I'll just go here. If I search for EKS, I will be seeing this in the drop down and I can click on it. And yeah, so now Kubernetes, it's a little more complex compared to ECS, which has a cluster, could have the services created along with tasks created. But with Kubernetes, it's a lot more tools that need to go in. And just to show the process I had to go through, I have done this setup because if I had to do this right now, it would have taken me a long time. So just to show you all, this is the setup I had to do. And it took around 30 minutes where let me try expanding, where what I had done was I ran these commands. That is, I had to first install kubectl, and that is where I set it up. I had to provide the permissions to kubectl, create the required directory, and then provide EKS kettle as well. I wanted to download it. It's a little bit more options compared to kubectl. This is where my token, SSS token, I had to provide so that I'm able to use kubectl. And this is using the EKS kettle, I'm able to create the cluster. This is what I used as part of the creating cluster. And now we could see this is the cluster it created. And so let me quickly show you the setup for the cluster. So this is the EKS cluster that is created. Now we can see the GUI. This is the new GUI compared to the older GUI that is there. This provides you a lot more option over here. Now, in EKS, we see that this is the API server endpoint, and this is the OpenID server endpoint. The role that is required for ECS is kind of mandatory to have this ECS setup, while EKS setup. While in ECS, we saw that we didn't have to create a role. All we had to do was provide just a cluster. And in this cluster, we're going to create the services and the tasks. Now, this is where I'll show you the comparison. But again, coming to EKS here, I could have all these setup done. And now these are the resources. You see there are lots of resources here that are there in Kubernetes, which again gives the impression of it being a lot more complex compared to ECS, which if you see here, we could create a service out here. I could create a service. I could say this is a capacity provider strategy, something that is recommended to use. And that's where we could get into the next topic, that rather than launch type, this is recommended. We could choose the capacity provider. What is the algorithm? And each service, it can have a separate capacity provider attached, or we could have multiple services using one capacity provider as well. So that is the fundamentals that we educate a customer, that when to use which scenario. In case you want to do isolation, or if you want to use resource optimization, we are better off using one capacity provider for multiple services. And this is the application deployment configuration, application type service versus task. Now, we have seen both scenarios where, like we at Arina Technologies, we recommend customers to use a service where we think that this is the better pattern. This is the ideal pattern to use specifically for microservices architecture. And what we have also seen is customers directly using a task as part of the cluster, which we think is an anti-pattern, which is something that we shouldn't be done. Now, but AWS does provide an option for scenarios of that. But for the purpose of this, let's choose a service here. You could provide the task revision. And I don't have any task definition. Task definition is something I will be creating if I am able to set it up. But let me just show you how I can go about creating a task definition. So if I have to choose it, I could create a new task definition and I could give it a name. All right. Task def example. And I could choose EC target or over here. And this is where I'll be able to choose the architecture, the memory, the role I'll have to create, and then accordingly create a new role. And this is where I'll be choosing the container, whether it's a WordPress or some other container I could create, but this is where I'll be providing all this. So once I create this, I'll be able to see in my option the task which I can use and provide a service name if I do test service. And this is where I would be having multiple options. What is the replica strategy I could use? And then how many tasks the cluster should it? This is where auto-scaling will also come into picture. The deployment options, whether it's a rolling or blueprint, And then what is the minimum and maximum percentages that one needs to ensure for monitoring purposes. Now, this is where these are the advanced concepts, something that we can go into. This is part of the service discovery, the service mesh scenario, something for more advanced topics. And this is where you see this is the VPC. It has used the default VPC. It creates the subnet. And ideally, you'd want to have this turned off because you wouldn't want the cluster sitting in a public subnet and then the application is able to connect to it. But rather, you would want the cluster fronted by a load balancer, which would do, will have a public, internet facing or internal load balancer, you could have it, but definitely not a public IP, because public IP, first of all, is going to be very expensive, and secondly, it's going to make your cluster insecure if you expose it directly. So definitely you would want to have a load balancer fronted with a WAF, and that's what we recommend to all our customers. But this is how you would go about creating a service. And if I see now comparing it with the Kubernetes, now this is where we see we have a different terminology where we have a cluster, but what we have is we have pods and nodes. In here we have a service and we have tasks, but that is where we have a node, which is you have it as part of, it's analogous to a service, while a pod is analogous to a task. It's a task definition or a container, and node is also a container in Kubernetes. So that is the terminology difference that is used as part of the setup. But if I see here, I could see these are the nodes that are there. And then if namespaces are going to be similar. I could have these default namespaces, something that I just set it up to show. And then if I do the workloads, I could come here and the different pods that could be used as part of the setup. And in compute, right, I could have a node group that could be created. Actually, I'm sitting in Virginia. Let me go to Oregon because that's where I had created the cluster. This is the cluster I had created for this particular purpose. And so this is the different regions we could have the setup. This is the role that was created as part of I created as part of the cluster. Just to quickly show you what it is, the permissions that it requires. And this is one of the permissions, right? So it requires the cluster policy, resource controller, but it requires the CloudWatch, as well as the EC2 permissions that are there. And now if we go here to the resources, we would see that this is the cluster here. And if I go to the nodes, or if I go to the compute section, I could see the group name here that is there. And then if I go here, I could see the different node on and the capacity of the VM and then the auto scaling. Now in ECS, what you do is you have the auto scaling. If you're using Fargate, it is kind of out of the box. If you do it as a VM, what you would need to do is you would need to, let me close this tab. But if you come to ECS and if you choose the capacity provider as Fargate, but if you choose it as, there was this option of, let me start here and show. Here you could have the option of EC2 as part of the setup. And you could always attach this to the capacity provider. But this is, now I have not spun up any EC2, but you could have this option. You could provide it as part of the setup. Similarly, in Kubernetes, you could also do that. But where you do auto-scaling as part of an EC2 instance, this is where, let me go here. And this is where we have auto-scaling groups. Now, this is a section where we will be creating auto-scaling groups that are set up as part of, we will be creating an auto-scaling group. A launch template is what we will be selecting. If I go here, I'll be providing all the value here. I'll provide the name, information, the tags. If any source template I need to refer, build out of that, I could do. Any base AMI I need to use, I could choose it. A few things, what is the instance type? If I don't want to choose, but ideally you would want to have it because you would want to ensure that you choose a certain configuration that best works for your application. So that is where you would want to choose. The subnet, you don't want to put it to tier. You are better off putting in the auto-scaling group. So something you're better off just leaving it. Storage volumes, in case you have to persist the data for a microservices architecture. Something that is not many applications have the use case for, but there could be scenarios where you want to persist. So something to look into. But rich and advanced details, you may want to ensure that you do have these profiles created, and ideally we would want to have all this done by Terraform, a cloud formation. But something, if you want to do it manually, you could always come in here. And then as part of the optimized instances you could do, capacity reservation, and lot of options out here that one could do. Now, this is where metadata, you would want to have this as enabled, all right, because what it does is that you provide a little more security features, as well as, say, metadata version, you would want to choose as V2, so that, again, this is a lot more secure option compared to choosing the V2. As something is, well, let me know if you want to get a little more detail about these different things, and I can definitely walk you through. But the whole point is, if you're using EC2, you will have to create a launch template and then ensure that, okay, and create the required alarms, that a particular instance goes above a certain threshold, it will be able to scale up to a certain max number of instances that you provide. So that is where, and now this is where you provide all this setting as part of the auto scaling group. And let me show you this setting here for Kubernetes. It's going to be similar. It's not going to be any different, but this is where you see it's an Oregon. It's going to be similar as part of because over here I have a VM and I choose the activity, and this is where I choose automatic scaling. I choose instance management. And this is where I have the other instances that I have set up as part of Kubernetes. You see, this is where I see the instances. And if I go here, I'll be able to see those instances that are running as part of this setup now. Right. So if I go here, I'll be able to see those instances that are running and have my cluster deployed over here. So this is where, right, there are certain distinctions. ECS is a lot more simpler compared to Kubernetes, but there's a lot better ecosystem for Kubernetes compared to ECS. And that's what we usually recommend to our customers, that, okay, just consider that aspect as well. It's not that how quickly you could get your application running. So that is where one needs to look into. So that I hope this provides you a good overview about ECS and EKS. Please like, subscribe, share the video. Please contact us for any of your cloud requirements or cloud consulting requirements. We have decades of experience in cloud, and we can definitely help your organization take the right step in cloud. With that, thank you, and see you in the next video.